All right, let's talk about something we all use every single day, but maybe don't think about enough: energy. Specifically, where does the UK's power actually come from? Today, we're going to dive into that story. A really fascinating mix of old school fuels, brand new tech, and some seriously tough choices.
So, let's kick things off with a little puzzle. The population of the UK has been growing pretty steadily since the 70s, so you'd think our energy use would have gone through the roof, right? I mean, more people, more houses, more TVs, it just makes sense. But what if I told you that's not what happened at all?
Here's the twist. Our demand for energy hasn't really shot up. And the big reason for that is one simple word: efficiency. Seriously, the stuff we use has gotten so much smarter. The fridge in your kitchen, the light bulbs over your head, they use way less power than the models from a few decades ago. Plus, our homes are getting better at keeping heat in, thanks to better insulation. It's this quiet revolution that's made a huge difference.
So even though we're using energy a lot more wisely, we still need a whole lot of it, which brings us back to the main question: where does the power we do use come from? Let's start putting the pieces of the UK's energy puzzle together. Okay, first things first. A key term you're going to hear a lot is the energy mix. It's basically the country's energy recipe. All the different ingredients, from the petrol in our cars to the electricity charging our phones, all bundled together.
And here is what that mix looks like. Whoa, that giant slice? That's still fossil fuels, no question about it. But look at those other slices making their presence felt: renewables and nuclear power. This chart isn't just data, it's a picture of the past, present, and future of UK energy, all battling for a piece of the pie.
So let's start with that biggest piece. I mean, to really get where the UK is heading, you have to understand where it's been. And for a very long time, that story has been all about fossil fuels.
Meet the old guard: coal, oil, and natural gas. For more than a century, these guys have been the heavyweights, the absolute foundation of the UK's power. They've heated our homes, run our factories, and kept our cars moving. Now, coal use has plummeted, but natural gas and oil are still huge parts of the system.
And this really gets to the core dilemma. On the one hand, they're incredibly reliable. You flick a switch, and the power is just there. But on the other hand, you've got these massive challenges. They're a finite resource. When they're gone, they are gone for good. And of course, there's the big one. Burning them releases CO2, which is the main thing driving climate change.
But that is not where the story ends, not by a long shot. A new set of challengers has stepped into the ring. So let's talk about harnessing the power of nature itself.
These are the modern challengers, running on things that never ever run out: the wind, the sun, the water. Renewables are the fastest growing slice of that energy pie we saw earlier. And you can see it happening, right? We're talking about those huge offshore wind farms spinning out in the North Sea and more solar panels popping up on rooftops everywhere. But it's not all sunny skies and breezy days. Just like fossil fuels, renewables have their own pros and cons. The advantages are pretty obvious. The energy is clean when it's being generated, and nature just keeps on giving it to us. The downside, though, is very real. The big one is what engineers call variability, which is a fancy way of asking, what do you do on a cloudy, windless day? And then there's a really human problem. Sometimes people just don't want them nearby. And that leads us to a term you've probably heard: NIMBYism. It stands for not in my backyard. It's this idea that while most of us support renewable energy in theory, some people might say, yeah, I'm all for wind turbines, just not right there where I have to look at them. It's a real and significant hurdle for building new projects.
Okay, so we've got the old guard and the new challengers. But there's a third major player in this whole mix, and it doesn't really fit neatly into either of those boxes. Let's get into the nuclear question.
Nuclear power is, well, it's the controversial constant in the UK's energy debate. The basic idea is that you use uranium to create a truly massive amount of heat, which then makes electricity. And its number one selling point is a big one. It can generate a huge, steady supply of power without releasing any greenhouse gases while it's running.
But this brings us to the really extreme trade-offs at the heart of the nuclear debate. On one side, you have immense carbon-free power, but on the other side, you have the sky-high costs to build the plants in the first place, and then the enormous challenge of what to do with the radioactive waste, which has to be stored safely for literally thousands of years. You can see why people feel so strongly about it.
And that leads us to our final section, where we're going to look at a potential energy source that is maybe the most controversial of them all. Let's talk about fracking. So you've definitely heard the word fracking, but what is it really? Well, it's officially called hydraulic fracturing. It's a technique to get natural gas that's stuck deep underground in a type of rock called shale.
It's a pretty complex process, so let's just quickly break down how it actually works.
You can think of it in 4 main steps. First, they drill a well way down into that shale rock. Second, they pump a high-pressure mix of water, sand, and chemicals down there. Third, that pressure creates tiny cracks or fractures in the rock. And finally, those cracks let the trapped natural gas escape so it can be collected back up at the surface. Now, as you can probably guess, this whole process has lit a fire under a pretty fierce debate. On one side, supporters say, hey, this could give the UK its own secure source of energy and create jobs. But on the other side, opponents are raising some serious alarms about the environmental risks, like the chance of contaminating groundwater, or even causing small earthquakes.
And so that leaves us right here with a final, really tough question that gets to the very heart of the UK's energy problem. We all want our power to be 3 things: clean, cheap, and constant, always on. But as we've just seen, every single energy source involves a trade-off. You can't have it all. So if you could only pick 2 of those 3 for the UK's future, which would you choose? That's the billion-dollar question. Thanks for tuning in.